Building the impossible, they said it couldn't be done. Crossing the uncrossable with cables one by one. Gonna fight that wind, gonna fight that tide, gonna make it to the other side. Building the impossible, they said it could be done.
This is the bridge that couldn't be built. One man wanted to build it. For 10 years, they tried to stop him. Even if he did manage to build it, they said, an earthquake would tear it down. And anyway, it couldn't be built. It was impossible even for him, not with the winds and tides in these waters. And if he could, it would spoil the natural beauty of the harbour. In the end, it was his arguments that won, and they let him try the impossible. His name, John Strauss, and for him this was a very special bridge. He'd already built 399 bridges around the world, and this was going to be his dream, his 400th, across the Golden Gate of San Francisco Harbor. He started with 2 towers and built them to rise 746 feet above the bay. The one tower, the northern one, was set on rock. That was no trouble. But the southern tower had to be set in the water itself, in the channel that was over 300 feet deep, with a current running up to 20 knots. Twice the work was wrecked, once by a storm and once by a ship that rammed it in a fog. People demanded that the work must stop. But for over a year, John Strauss and his men struggled on. Out in what was virtually the open sea, they blasted bombs into the channel floor, and slowly, bit by bit, built what amounted to a 10-story block of foundations under the waves. At last, the 2 towers rose above the sea, but the fight to build the bridge had really only begun. During storms, the towers swayed so much that the men working on them got seasick. Then, at last, the day came when they were ready to send the first cable across.
We're all set here. Are you ready, Barge? Okay, we're coming across.
The first cable was across. Now the spinning operation could start. Before they could finish, they had to carry across that channel and up those towers 80,000 miles of wire. The men had to work against wind, storms, fog, and the currents always swirling below. It was to take them 3 years. But gradually, as the people who lived on the shores of San Francisco watched, the great steel arms crept slowly out over the sea, nearer and nearer. Inch by inch, the bridge builders struggled with the first attempt to put one single span across a major harbor, the longest single span ever to be built. And then, one day, real trouble developed on one of the cables. The work carriage carrying the cable broke down halfway across, right out over the bay. 2 of the builders volunteered to climb out and mend it. They did it, and the 2 of them became the first ones ever to travel right across the Golden Gate Bridge. Others weren't so lucky. Already the huge safety net slung beneath had caught and saved the lives of 19 men who had slipped and fallen. And then, one day, a wooden platform collapsed and crashed through the net. While struggling to build the bridge that couldn't be built, 10 of the builders had fallen to their deaths. The work went on. Gradually, the end was in sight. Already the job had taken 4 years. For his dream bridge, his 400th, and the one that no one else had thought it possible to build, John Strauss decided he needed a colour as new and different and as striking as the bridge itself. He called it International Orange, and by the time they'd finished, his painters had used 60,000 gallons of it, although not all of it went on the bridge. One workman, just to pass the time, devised a method of trapping seagulls. He then gave them a nice, colourful orange head and let them go. Before long, an article appeared in the local newspaper commenting with great excitement on the new species of orange-headed gull that had appeared in the bay. And then, at last, in May 1937, 4.5 years after the work had started, John Strauss finished his 400th bridge, the Golden Gate, the bridge that couldn't be built.
Man farms everything. He has to. And in Sweden, they farm trees. They have to. 1 in 5 of the ships that leave Sweden are carrying wood. In the forests are over 70 million acres of trees. But the Swedes cut down over 90 million cubic yards of forest each year. And to farm trees, they use machines. Giant machines for a giant crop. But not yet. These are the seeds which in 60 or 70 years will turn into trees. These need care and looking after, even though there are 250 million of them planted every year. At this stage, the work is done by hand. A good pair of hands can plant 10,000 in a day, and then machinery takes over. But still quite small machines for small seedlings. After a year, they're uprooted and then put back. By making the seedling take root all over again, you make it stronger. It's had to fight twice. And eventually, in 30, 40, 50, 100 years, there is a forest ready to be felled. By the time these trees are ready to be cut down, the hands that planted them have been dead for a generation. It takes a long time to grow a tree, and no time at all to cut it down. No more hands now. The machines take over. First, the machine the Swedes call the logma. It just picks up a tree, and when it's finished, the living tree is just a log. A violent, savage machine, but an efficient one. The idea now in the forests is no man on the ground, no hand on the timber. The machines will do it all, looking as if they had a life of their own. And once the logma has stripped the trees, it puts the logs in a pile. If they roll off, it goes back and does it again. Then, once the logma has finished, the next machine takes over. This time a giant tractor, a huge, powerful tank with great iron jaws. The tractor drags the logs across the clearing to where the third machine waits for them. And the final stage in the brutal humiliation and wreckage of what only a few minutes ago was a tree. From a small seedling, it has taken 100 years to grow, and the work of that 100 years takes just 2 seconds to cut. Power, efficiency, a long way from the woodman and his axe. But the machines rule the forest now. No man on the ground, no hand on the timber. Just the noise of a slaughterhouse of trees. And yet the machines are not entirely in command of the forest. As the tall trees fall and the logs are cut and dragged away, there are still some men on the ground. Soon, after the dead timber has gone to become another few cubic yards in that 91 million a year, the seedlings that have been growing in their neat rows are brought here and planted in the same soil that their forefathers have just fallen upon, by hand, or rather, by foot. Machines don't do this. After all, these are young, tender plants, and even a man's boot, it appears, is more careful than a machine.
Off the coast of Finland, the sea is on fire, and not by accident. It was done on purpose. It's a new way of tackling an old problem, oil. Everywhere along the coasts of Europe, oil is a nuisance, and sometimes a great deal worse. You can try to contain it by passing a boom like this around a tanker, but it still gets out. And what happens then has become far too familiar a sight. But now in Finland, they have found a new way of dealing with the oil. A new way that involves an old traditional industry here, the harvesting of peat. Finland has huge areas of peat bogs, some of them 6,000 years old, because peat takes a long time to form. Peat moss like this grows less than ½ an inch in a year. But you can't harvest a bog. First of all, you have to drain it, dig ditches, and try to get rid of as much of the water as you can. Even then, when you come to cut it, it is wet peat, and for its new use, it must be dry. So it has to be turned over and over until it has dried out to about 1/3 of its original weight. Then it can be collected and sent off. Until recently, it would have gone to be sold as fuel, to burn in Finnish homes, but not anymore. Not since these experiments here began, and they started as they did in so many countries after the Torrey Canyon disaster. Because what that proved was that the accepted methods of getting rid of oil were no good. The chemicals they used then to clear the oil did more harm to the wildlife, the plants and the animals, than the oil itself. So they had to find a new way. And in Finland they thought of peat. Because peat has certain properties. It is a fuel. It burns. But apart from that, they tried to see whether they could do something else as well. First, they dried it until its water content was less than 20% of what it was. And then they lured one sliver of peat into a tank of water and another into a tank of oil. The peat rejected the water, but it soaked up the oil. They tried again, this time with a mixture of oil and water. Once again, the peat soaked up the oil. You can see it happening here in this microscopic picture of one cell of peat moss. The cell is absorbing 4 times its own dry weight. Finally, they took handfuls of peat and sprinkled it over patches of oil floating in the water. The peat quickly soaked up the oil as they now knew it would. But then came the real test. They put a match to it to see whether it would still burn, even though resting in water. It did. What's more, they worked out that using peat like this is 20 times cheaper than any of the methods involving artificial chemical processes. Peat was the answer to the problem of totally getting rid of the oil without harming any of the surrounding wildlife. So now, when an oil slick is reported, the peat-burning team goes out. First, they try to contain the oil within a boom, as in other countries, except that here the boom has to be fireproof. Then, the peat is blown out onto the oil. This was the only really difficult part of the operation, to get peat dry enough to do the job, and yet not so light that it just blew away in the wind. After that, it's simple. You just set fire to the sea.